All right, so last time when we were looking at the construct understanding, there was at least one of those questions where you didn't actually move the arm. It just had a different angle. What's up with that? That's when you spin at 360 degrees or 720 degrees or whatever, and it ends up in the same position, but it's not exactly the same angle. Those are called coterminal angles. So when we talk about coterminal angles, we mean the arm is in the same position, but maybe it's been rotated all the way around or all the way back, and so you have to count those angles too, the angles that it's been rotated through. Now on example 1, it gives us the coterminal angle, or it asks us to find the coterminal angles for 150 degrees that are between negative 1,000 and 1,000 degrees. Now I warned you they're going to do this. So what we have to do is go, okay, well, coterminal with 150 degrees means it's been rotated 360 degrees, because that's what happens when you were back where you started. But how many times? Because 1,000 is almost 3 full rotations. So let's give it a try. Let's see. Let's use red. Why not? So we've got our 150 degrees, and we can go forward until we reach 1,000 degrees. So that means I can rotate this around again, which would be 150 plus 360 degrees. That's going to give me my first one. So 150 plus 360 is 510 degrees. So let's keep track of these up here. I've got 510 degrees, but I haven't reached 1,000 yet, so I'll give it another try. And I could just add another 360 degrees if you want to. Another 360 degrees, 870. So we'll add 870 up here. And we can pretty much ballpark, if we added another 360 degrees, we're over the 1,000 limit, so we're done. So what we've done is take this another round out, and let's just color code that a little bit. That's given us our 870 degrees. Now, that's great for the forward direction, but we have a backward direction to go as well. So the first one would start from here and go to that line. So we've got 180 degrees here, and then a little bit. But rather than try to figure out what the little bit is, we can just recognize that it's 150 degrees short of 360 degrees. So for the negative ones, I can go 360 minus 150 degrees, which is going to give me 210 degrees in the negative direction. So that's negative 210 degrees there. And that's obviously not negative 1,000, so I can keep going. So this time, I'm just going to pop out to the outside here, and that was negative 210. And I'm just going to keep going all the way around, and you can see that I just took another 360 degrees. So, but in the negative direction. So I can go, okay, well, another negative 360 from there gives me 570 degrees in the negative direction. So I just added them up. So now I've got negative 570 degrees as well. Now if I add another 360 to 570, is this still going to be under the 1,000? We can give it a shot. Another 360. Ooh, hope you can see that. 930 degrees. So we can go another round and still make it just under the 1,000. So I've got negative 930 degrees. If you can't see this very well, it's in your textbook anyway. We're on page 469. So we have basically been looking at it in terms of 360 degrees. So B of this question goes, well, what if you didn't want to like muck around with all of this? What if you wanted to just use a formula? Then the formula would have to be 150 degrees, because that's my starting point, plus some constant times 360 degrees. And we would specify that the constant is actually in the realm of z, which is integers. That's an old thing we haven't looked at for a while, but this just means integers. It means I'm not going to have 1.5 or anything like that. It's just like whole numbers, but they can be positive or negative. So if I use this, I can get all these values because really all we did was skip count by 360.